In 2026, the National Electrical Code introduced structural shifts that many engineers are reading but not fully interpreting. And that distinction matters, because the code is not just compliance, it is a reflection of failure history. Today, I want to walk through 4 NEC 2026 areas engineers are misunderstanding, not from a textbook perspective, from a system behavior perspective. Let's start with transformer grounding. Article 250.30A and Article 250.50. On paper, grounding a transformer looks simple. Drive a rod, add a grounding electrode conductor, draw the symbol. But 250.30A requires correct bonding of separately derived systems, and 250.50 requires bonding to the building grounding electrode system. If you drive a single rod and fail to bond to the building grounding electrode system, you create a difference in potential during a fault. That difference will never show up on your one line. It shows up when fault current takes unintended paths. Engineering is not about symbolism. It is about controlling current return paths. Grounding is not decorative, it is physics, and physics does not negotiate with inspection checklists. Now let's talk about workspace versus egress. Article 110.26 defines workspace. But workspace is not the same as egress. Workspace is about maintenance. Egress is about escape. If a door swing meets clearance but blocks your exit path, you may comply dimensionally, but fail practically. Clearance is not just about standing space, it is about survivability. Clearance is measured, egress is experienced, and those are not the same thing. Now voltage drop. It appears in informational notes. Informational notes are not enforceable. Inspectors cannot mandate them, but engineers should not ignore them. This is where professional judgment matters. Minimum code is a floor, not a performance target. Article 625 is evolving. Emergency shutoff requirements for EVSE are expanding. Thermal runaway considerations are influencing parking design, fire separation, and equipment layout. The NEC is reacting to real-world system behavior. Are we? Here is the real issue. Engineers focus on compliance. Instead of consequence, the code tells you what is required. It does not tell you what happens when systems fail. That is our responsibility. If this analysis helps you interpret NEC 2026 more critically, subscribe. And tell me in the comments, what do you think about this new feature? Is it something you find useful, or do you have suggestions for improvement? I can't wait to hear your thoughts. What NEC 2026 change do you believe is being misunderstood right now? Let's discuss it like engineers. This is the practical electrical engineer.